Alright, so regarding Bertrand's paradox, while I was explaining what I was seeing about it, I I got to the point where I felt like I could explain why all of the probabilities were operating the way that they were. And then I came to a point where I realized that I made a mistake with the 1/3 versus 2/3 thing. So, what's happening there, let me get this out of the way for a second. You're picking a point, and then you're choosing a random point on the perimeter to connect to that point to get your chord, right? Okay. And what ends up happening is 2/3 of the time you end up with a chord shorter than the side length of the triangle, because I can land anywhere here or anywhere here, and 1/3 of the time I end up longer. Now, I mistakenly took this to mean that this was looking at chords of random length. It's not. It's looking at arcs of random length. But once I realized this, this means that there is a fourth way to look at this. What we could do is, taking this same figure, we could start from a point and then just randomly determine the length of the chord and then find where it'll fit. We really only need half of the circle for this, because every length is going to have two options except for the full length or zero length. Any other length that you're going to have two options, right? If it's short, it could go that way or that way. If it's long, it could go that way or that way, something like that, right? So really, you kind of only need half of the circle for that, but that's fine. So this is going to be a fourth method, and I figured it would be interesting to look at what are the probabilities here. What is because this is an as far as I know, an unattested one. I don't know. I just heard about this yesterday when I saw the number file video. So, I don't know anything. Anyway, so basically what we've got is we've got our circle, right, with our inscribed triangle. Now I'm doing it sloppy. That's fine. Okay. So, really, what we need here is we need this to be so just to make the numbers the easiest. The length of this guy should be 1. So the length of your circle, or like the diameter of your circle, is 1. And now we want to know, well, how long is one of these sides if the entire diameter is 1? Okay, well, so here's your center. So from the center to one of the vertices, it's going to be 1/2. That's easy, because, whatever. And then to here, we know that this length and this length are the same, so this is going to be 1/4. So that total length, the total height of the triangle, is going to be 3/4. So our triangle is 3/4 tall compared to the diameter of 1 on your circle. Alright, now let's draw this out a little bit nicer. So I've got, now this is going to be 1, 2, √3. Right? Because if we square these, what happens? Square that, I get 3. Square that, I get 1. Add them together, I get 4. Square root of that is 2. So there you go. Right. So here's our small angle, and here's our large angle, and that is going to be 60 degrees and 30 degrees, or whatever you want to do in radians. Anyway, so what I want to do is find an analogous triangle that has 3/4 for its height. Alright, so there's our basic triangle. there's a 3/4 for the height. And what we want is this. And basically, once we have that number, the problem is solved. Because whatever number, because I set this to 1, our chords can be any length from 0 to 1. And your long chord just has to be longer than one of these side lengths. So we just need to know what one of those side lengths is. And then we're golden. Basically the space above that, treat this as like a percent. The space above it is the where the long ones can be. Okay, so I want to convert √3 to 3/4, so I want to divide by √3 and multiply by 3/4. I'm interested in the 2, so 2 on √3 by 3/4. Same thing would happen here, but I don't really care. So 1 on √3 by 3/4. That will get these guys working together nicely. So these should now be similar. I'm really only interested in this one. Okay, so on the top I'm going to get, let's bring this down here, I'm going to get 6 √3 on 3 times 4, 12. Well, that is √3 on 2. Okay, so √3 on 2 out of 1 is going to be the how often you get short ones, and 1 minus, so short is going to be √3 on 2 to 1, and long is going to be 1 minus √3 on 2 to 1. That's different than 1/2, 1/4, and 1/3. Let's see, what does that look like? I haven't even run a calculation on this. Like, what does that look like on as like a, there we go, as like a percent. Okay, so √3 on 2, and then, ooh, that's a small number. 1 minus that. It's something like 13.4%. And this one was about 86.6%. Yeah. So the short ones, if we're just choosing random lengths between 0 and 1, 86.6% of them are going to be short, and 13.4% of them are going to be long. That's kind of amazing. I wasn't expecting it to pan out that way. But that is radically different from the other 3 methods. And this is when we're randomly choosing chord length. So there you go.